So, and if you'll notice at the top, there's this x, the x value, that's the x value for all of them, and these are the y values. I hate them written horizontally, personally, but lots and lots of textbook writers do it that way, and you'll see it a lot that way, so we're going to practice them both ways. I prefer the vertical, but you kind of have to get used to seeing them both ways. Okay, so we all know, because we're very familiar, that if the x is not inside the parentheses, but a number is, that means that's the x value. So this notation right here, h of 0, means that's the y value where h is 0. So I go up to h of 0 and I get 2. So this is actually 2. So I have negative 3 times 2 times g of negative 3. So I go up to negative 3 and the g value would be negative 2. And then you're just multiplying. So negative 3 times 2 is negative 6, times negative 2 is 12. That's it. You're just basically pulling numbers out of the function. You're finding the definition of the function at that point. So this one is 2 times g of negative 1. So I go up to negative 1. The g value there is 7. F of negative 2 is 3. That is 14 thirds. So far so good? Easy enough? Okay, so the next one, h of negative 2 is negative 1 plus 3 times g of negative 1 . I got 20. Everybody okay? Okay, so the next notation, they kind of just try to shorten the notation by writing it this way, h times f of 2. It actually means this, h of 2 times f of 2. So I'll go up to the function table, find h of 2, which is 0, times f of 2, which is 3, and that gives me 0. Alright, so far so good? Okay, so this next one is what we call a composite function. It's a function inside of another function, and you work these from the inside out. So we do the f of 2 piece first. So I go up here and I go to 2. F of 2 is 3, which means I now have h of 3. Then I go to 3 and find h of 3, and my answer is negative 1. So again, it's a composite function. You work from the inside out. So I do this inside piece first, f of negative 3. So I go up to negative 3. F of negative 3 is 0. So that would leave me with g of 0. So then I go to 0, find my g value, and it is negative 2. Easy enough? Okay, so you do g and h. Actually, do g, h, and I, and I'll give you answers and see how you do. So I go to g of negative 2, and it's 1. So then I have to go to h of 1, which is negative 3. So I go to f of 3, and that gives me 2. So now I have g of 2, which is 5. H of 1 is negative 3. So then I go to f of negative 3, which is 0. Everybody good? Isn't this easy? I told you it was easy. I know y'all don't believe me most of the time when I say that, but it really is. Okay, so J, K, and L It's all the exact same thing, only you have to do it twice. Because now I have a composite function. By the way, if you were reading this, you would say h of g of f of 2. That's how you would read it. So I'm going to go to f of 2 first, and I get 3, so that would be h of g of 3. Then I have to go to g of 3, that's negative 3. So now I go to h of negative 3, that's a half. So I go to f of negative 1, and that gives me 2. So now I have to go to h of 2, which is 0, and g of 0 is negative 2. Oh, you know what? Honestly, you don't even have to write out these steps. On these, they're so easy. You can just go and find the final answer. I'm just writing it for anybody who needs to follow.
Yeah, but is there a question like where it gives you the answer and you gotta
Go backwards?
Yeah.
I don't think so. I hope not. Because that would definitely be harder. That would definitely be a lot harder. G of F. G. Oh. Negative 2. This one used the same function twice. I went g of f of g. That's okay. It doesn't matter. You can go back and forth many times. Okay, so these really are pretty easy. So this next question, same process. See, I need to find f of g of h in order to set it equal to this new function k. So let's find that, f of g of h of negative 1. So I got negative 4. So then you're just going to take your, because this said k of x equals all that, I'm going to set k of x, which is 2x plus 10, equal to negative 4. And then just solve. And I got x equals negative 7. Same thing for n. Let's take care of the composite function first. So I'm going to find f of g of negative 2, which is f of 1. So f of g of negative 2 equals 4. So now I need to set p of x equal to 4. Remember when you solve an absolute value equation, if you think about what absolute value looks like, it's a V. So you gotta have two answers, because that line going through is gonna produce two answers more than likely. So don't forget, you gotta split it into two equations. 2x minus 3 equals negative 4, and 2x minus 3 equals 4. So I got x equals negative 1/2 and x equals 7/2. Y'all okay? Alright, on the next page, it's the same process, only this time we don't have a table to look at, but we have a graph. But we're doing the exact same thing. We're going to go get y values off of our graph. So the first one, it says negative 3 times f of 2. So I have to go to f of 2 and get my value. It's 2. That's negative 3 times 2. G of negative 3 is negative 2. So I got negative 6 plus negative 2, which is negative 8. For B, I go to G of 3 first, so you're just going on your G. Make sure you just keep track of which one's which. So this is my G graph. I'm going over to 3, so G of 3 is 1, minus f of negative 1, which is negative 3. That's really 1 plus 3, which is 4. G of negative 2 is 0, times f of 3, which is 3. 0 times 3 is 0. So these are composite functions, so you're going to do the same thing. We're going back and forth between graphs. So I go to f of negative 1, and I get negative 3. Then I'm going to go over here to g of negative 3, and I get negative 2. So you do not have to write the middle step. If you don't need it, you don't have to write it. So this time I'm going g of 0. G of 0 is 2. So now I have to go to f of 2, which is 2. Starting, always working from the inside out, so I start with f of negative 2, which is negative 1. Now I have to go to g of negative 1, which is 3. So you do g, h, and I, and j, and k, and l. And I'll put them up in just a second and see how you do. G, I got 0. H, I got negative 1. I got 3. J, I got 1. K, 2. And L, 3. Any questions on any of this? Don't you wish the whole unit could be this easy? Okay. Again, same thing at the bottom. We need to find the composite function. And then it says the composite function is equal to the new function h. So we're just going to go use our graphs and find the composite function. So f of 1 is 0, g of 0 is 2. So I need to set my new function h, x squared minus x equals 2. I need to solve that. I've got an x squared and an x in the same problem. The only way to solve that is to move it all to one side and either use the quadratic formula or factor it if it'll factor. So I'm going to move this 2 over. So I have x squared minus x minus 2 equals 0. Thankfully it does factor, so I don't have to use quadratic formula. X minus 2, x plus 1. So that means x minus 2 equals 0, and so does x plus 1. So x equals 2, and x equals negative 1. So go ahead and try in, same way. Okay, so when I get right here, I found my composite. So I went to g of negative 2, got 0, went to f of 0, got negative 2. So then I set my new function equal to -2, and then I'm going to try to solve this. First thing you have to do, with absolute values, you must isolate the absolute value. So right now it has a 3 in front of it, so I'm going to divide by 3. And I have an absolute value equals -2/3. Now you can stop right here, because what does an absolute value do? It is distance from 0, but what does it actually do to a number? It makes it positive. So is there any way that an absolute value all by itself can get a negative answer? Never, because an absolute value makes everything positive. So this is no solution.
I thought there was a positive number.
Except for, see, if you were to go ahead and try that and break it down and put it in 2 answers, they're extraneous answers. Because if you plug them back in, they will never equal -2/3. Okay. So we did it with a table. We did composites with a graph. Now we're going to do them with just the equations. Process is the same. Pretty simple. So working from the inside out, you always go to the inside function first. So I'm going h of 4. So here's my h function. I'm going to find h of 4. That's going to be 3/2 times 4 minus 2. So h of 4 gave me 4. Now I have to find g of 4. So your final answer is -7. Really, the only thing you have to be careful about these is just making sure you plug into the correct function. So f of -2, I find my f function, and I'm plugging -2 in for every x value. Find my p of 2 value. Now I have to do what it said at the top. Once I have found f of -2 and p of 2, I have to add them together. So I get -15 plus -4, which is -19. Working from the inside out, going to g of -1 first. So I find my g function and I plug -1 in. And now I'm going to find p of 3.
Isn't number 2 like on part of negative? Put a negative in the negative, isn't that positive? So that one.
Right here? But I squared you square it first, because please excuse my dear Sally. So when I square -2, it becomes positive. Okay, so when I plug p of 3 and I get 3 plus 2 over 3 minus 3, that's 5 divided by 0, which cannot happen. This is undefined. Okay, so on task number 1, using the 2 functions they gave you, here's f of x and here's g of x. Go ahead and find this composite. Work from the inside out. So find that one real quick. did g of -2 and that gave me -3, so I have to plug -3 in. Make sure you follow order of operations, so square this first. So I end up getting 29. Okay, so on task 2, they've asked me to plug in, find an equation for f of g of x. No numbers to plug in. When they write it like this, they want you to actually plug the equation into the other equation. So working from the inside out, g is going into f. So this 2x plus 1 is going into this equation everywhere that there's an x. So in both spots there's an x. So I have 2, that was part of the function. Where there was an x, I'm putting 2x plus 1. And that x was squared, so this has to be squared. -3. And there was an x there, so now it's going to be 2x plus 1 plus 2. Everybody understand what I just did? So these x values right here became, instead of just x's, this whole thing. So this was an x, now it's 2x plus 1. Now we have to simplify. So first thing I'm going to do is take this squared value and write it next to itself so I don't confuse myself. Squaring something means that value times itself. Now I do that because I know you can square that in your head, but I don't want anybody to accidentally put 4x plus 1 squared or anything, 4x squared plus 1 squared. You have to FOIL that. Now right here, you have two choices. You can distribute this 2 into just the first piece, because anytime you hit a closing parentheses, you have to stop. Or you can FOIL first. It doesn't matter, you're going to get the same answer either way. I FOIL first, that's just kind of my habit. So I'm going to leave this 2 out here, and I'm going to FOIL the inside. Okay, my next step is going to be to distribute this 2. So that's going to give me 8x squared plus 8x plus 2. I'm going to go ahead and distribute this -3 also. Minus 6x minus 3. And there was a plus 2. Now combine any like terms that you can combine. There's no other x squared, so 8x squared. 8x minus 6x, so that's going to be plus 2x. 2 minus 3 plus 2